Welcome back everyone with another video in our calculus series. In this video, we're applying the limit of a function graphically. So the question is asking us to give the value for the following limits based on the graph of f of x. This is the graph of f of x, and they want us to answer these four questions based off of this graph. Remember, an important note is that the limit is not concerned with where the function is at that point. It's concerned with where the function is approaching. Limits are concerned with where the function is approaching. Not where they're defined. So let's take letter A for example. The limit as x approaches 3 of f of x. I'm going to go to 3 on my x-axis, and I'm taking the limit of f of x, so I'm heading up to the graph of f of x. Now, if the question was, what is the answer to f of 3? This is asking where the function is at 3. So if we go to 3 and head up on our graph, we see that there's an open circle there. And so the point is not defined. How do we signify that from our first video? We said if there's no point when I go, then we say f of 3 is undefined. But it doesn't matter that this function is not defined at 3 because limits are only concerned with where f of x approaches, not where it's defined. So when I'm dealing with 3, recall from that special theorem, the limit as x approaches 3 of f of x is only equal to some value if and only if the limit from the left side of 3 of f of x is equal to the limit from the right side of 3 of f of x. So I have to calculate the limit from the left and the limit from the right. So here's 3. We're going to take the values very, very, very close to the function from the left side. And we see when I'm approaching 3 from the left-hand side of 3, the function is going to about 1.5. It's getting closer and closer and closer to about 1.5. So the limit from the left side is about 1.5. Now we go on the other side. Let's do this. On the other side, the right side of 3, as I'm going closer and closer and closer to 3 from the right-handed side, I'm getting also very, very close to 1.5. So the limit on my left side and the limit on my right side are equal. Therefore, the overall limit as x approaches 3 is also about 1.5. So that's for the function at 3. And recall again that f of 3 is undefined because this point is not closed. It's an open circle, but limits are not concerned with where the function is at that point. They're concerned with where the function approaches. I'm going to repeat this a lot because this is the most common misconception with limits. People think that limits are where the function is, when in reality, limits are where the function approaches. So make sure you make a note of that. Let's deal with the next one. The limit as x approaches 1 of f of x. We're going to go to 1 on my graph. Here's 1. And we're always going to go not to the point because limits are not concerned with where the function is. They're concerned with where the function approaches. So we're going to go down to my graph, which is over here. Notice how this point is also not defined on my function. It's defined up here. So if I ask you another question, what's f of 1? F of 1 is asking where the function is. So where's the function defined? It's defined at this point. It's at point 1. This is from algebra, dealing with points that are defined versus undefined. But the limit is asking where my function is approaching. So we're going to do, again, the left-handed limit and the right-handed limit. So the limit as x approaches 1 from the left of f of x has to equal the limit as x approaches 1 from the right of f of x. So let's look at it. The limit as x approaches 1 from the left side is taking these values, and you see that we're getting closer and closer and closer to negative 1. From the right-hand side, we're getting closer and closer and closer to negative 1 as well. So they are equal, and so therefore the overall limit as x approaches 1 is negative 1. whereas the function at 1, or the function evaluated at 1, is just 1. So notice how the limit differs from where the point is. In the case of 3, we didn't have an explicit point defined for the function at 3. So that's why it was undefined. Whereas at -1, or at 1, the limit was defined for -1, but the point was defined at 1. So notice the difference between here and here. This is the area for the limit. This is where the function is evaluated at 1. Notice the difference. The limit, now we're concerned with the limit as x approaches 2. So we go to 2 on our graph, and we go up. Well, we notice that there's a split in our function. We call this a jump or a piecewise function because the function is in 2 different directions at 2. Again, we're going to take the limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. And these two have to be equal. So let's do the left first. If I go to 2, the left side function is right here. The values are approaching about 1 from the left. Now if I do the right, here's the right side of my function at 2. The values are approaching about 2. Well, unlike this case where the left and the right were equal, the left and the right here are not equal. So we said that if the limit as x approaches 2 from the left of f of x is not equal to the limit as x approaches 2 from the right of f of x, then what happens? The limit does not exist. Why? Because of this statement right here. The limit from the left and the right are not equal, therefore the function or the limit at 2 does not exist. Now what if I ask you for f of 2? F of 2 is concerned with the point at 2, so where is the point defined? Here we have an open circle, here we have a closed circle, so we're going to take the point f of 2 is 1, not 2, because 2 is an open circle at 2 here, it's a closed circle here at 1. At 2 it's open, at 1 it's closed, so f of 2 is equal to 1. Again, this concept has nothing to do with limits, but it gets people tripped up sometimes when they look at the difference between the function and the limit. This is independent of the limit. This is where the function is at that point. This is where the function approaches at that point. And the last one here, the limit as x approaches -3. So we go to -3 on our graph, and we take it from the left and the right. We can do the left side, and we see that it's approaching about 1. And then we take it from the right side, it's approaching about 1 as well. So therefore, the limit as x approaches -3 of f of x is 1. Notice how I didn't write the left and the right-handed limits in letter D, because once you get really good at this, you automatically in your head imply that this statement is asking you for the left and the right-handed limits. And so unless it's a piecewise or a jump function, you don't always have to explicitly write the left and the right-handed limits. You can do it in your head. Well, the left is going to 1, the right is going to 1, because I visualize that the function is going to the same point. I just write the limit as x approaches -3 of f of x is equal to 1. If I ask for f of -3, we see that there is no point here, and so this would be undefined. And so this is the first example on how to calculate limits algebraically. I'm sorry, how to calculate limits. This is the first example on how to calculate limits graphically. And so when we're dealing with limits graphically, we always have to, in our heads, make sure we're testing from the left and the right-handed side of the limit. And we have to know the difference between the function defined at a point versus the limit at that point. That's it for now. This is Ahmed signing off.